Hello class, welcome to the next segment in lecture 10, and in this segment we're going to start exploring some of the finer details of natural coordinates, more specifically the mathematical details of the natural coordinate system. So with that, let's go ahead and dive right into it. So just to sort of refresh your memory, the Cartesian wind vector, which we introduced way back in lecture 1, was defined as follows. So the wind vector is zonal component times I hat unit vector plus the vernal component times the j hat unit vector plus w, the vertical component times the k hat unit vector. Now let's take a look at how this wind vector actually changes when we go to work in our natural coordinate system. So instead of I hat, j hat, k hat, what we typically use to denote the tangential and normal axes is we use t hat, n hat, but the vertical coordinate is still the same. The only thing that we're changing is the horizontal coordinate. So when we implement those changes, we get something that looks like this. So in natural coordinates, our wind vector would be represented as follows, where wind is equal to the magnitude of the wind, v, times t hat, which again is pointing in the same direction as our t-axis, our tangential axis. And since the normal axis points 90 degrees to the left, then the component of the wind that goes in that direction is just 0. And then the vertical component is still the same. So by implementing that change, you can see that we went from something that has 3 components to something that has 2 components. So here our wind vector is just the magnitude of the wind times the t hat unit vector, which points in the same direction as the wind, plus the vertical component of the wind, which is just the same as it is in Cartesian coordinates. Now let me go ahead and pose, well first let me discuss something here. So a lot of times you'll see this capital V also defined as this ds dt term, where ds is the total distance traveled. So if you sort of think about how parcel is moving along, it traces out some distance, and that's represented by this ds term, and then dt is defined as time. So instead of dx dt and dy dt to represent our Cartesian velocities, this ds dt just is used to represent how the distance changes with time in our natural coordinate system. Now let me go ahead and pose the following question for you. Can v, this capital V, ever be negative? Even feel free to pause the video for a few seconds and see if you can come up with a justifiable answer. So let's go ahead and answer this question. Can v be negative? And the answer is no. V cannot be negative. And let's actually go ahead and explore why. So let's consider a wind vector that we had earlier. It's the exact same wind vector. You can see how we define our coordinate system so that the positive t direction points in the same direction as the wind. So that means this v, the wind, the component of the wind that goes in the t hat direction has to be positive because the wind is pointing in the same direction as the axis. And if you try flipping that around, something like this, the t-axis also flips around with it. So even if we turn this wind 180 degrees and send it in the opposite direction, that also sends the t hat axis in the same direction as the wind. So that means that even though we flipped everything around, this is still pointing, the wind is still pointing in the positive t direction, in the positive tangential axis direction, which means the component that goes in the positive t direction is still positive. And this is something that's really important to keep in mind, is that the fact that this wind, this symbol here, capital V, which represents the magnitude of the wind, that must be positive at all times. And we'll see why we have to keep that in mind in some, and I believe it's the next lecture when we talk about the solutions to the gradient wind balance, but we'll cross that bridge when we come to it. But just something important to keep in mind is that V cannot be negative. So that's actually going to do it for this segment, and in the next segment we are going to explore some more of the mathematics behind natural coordinates. So with that, I will see you all in the next segment.